What's up, guys? So, today we're going to be talking about chromosome structure and function, and this is again in conjunction with Elizabeth Williams. My name's Herman. So let's jump right into it. So we're going to be talking about, um, chromosomal structure, how variations happen in chromosomes. Um, so we'll be talking about deletion, duplication, inversiones, translocation, and the variations in chromosomal numbers. I will do the first 2 points, and Elizabeth is going to be doing the latter. So let's keep it going. So deletions. A deletion is a type of a chromosomal mutation that involves the loss of a segment of DNA from a chromosome. Deletions can occur in any chromosome and can range in size from a single nucleotide to an entire chromosomal arm. There are different types of deletions. We have terminal deletions, interstitial deletions, microdeletions. A terminal deletion occurs when a segment of DNA is lost from the end of a chromosome. Interstitial occurs when a segment of DNA is lost from within a chromosome. And a microdeletion is a small deletion that involves the loss of a few thousand to tens of thousands of nucleotides. Um, there are several causes of deletions. Um, some of these are errors, some of these are programmed. Errors during DNA replication. These deletions occur due to errors during DNA replication, of course, such as a misincorporation of nucleotides or slippage of the DNA polymerase. Exposure to mutagens. We talked about this before, like an exposure to a toxin or to a what would you say, a certain environmental factor. This affects your genome. Deletions that occur during exposure to mutagens such as radiation or chemicals. Viral infections. Deletions can occur due to viral infections such as the human papillomavirus or HPV. Um, some effects of deletions. Genetic disorders. Deletions can lead to genetic disorders such as Williams syndrome, Prader-Willi syndrome, and DeGeorge syndrome. Cancer. Deletions can contribute to the development of cancer by disrupting tumor suppressor genes or activating oncogenes. I believe this might be somewhat correlated to apoptosis. Um, I'll have to look more into that. That's actually rather interesting. Birth defects. Deletions can lead to birth defects such as heart defects, cleft palate, limb abnormalities. Um, we have some diagnosis or means of diagnosing deletions. Karyotyping involves the analysis of chromosomes to detect deletions. Fish, we've discussed fish. I love fish. Fluorescence and in situ hybridization. It involves the use of fluorescent probes to detect specific DNA sequences and detect deletions. And then we have chromosomal microarray analysis, which involves the use of microarrays to detect deletions. So let's move on to the next point. Duplication is a type of chromosomal mutation that involves the copying of a segment of DNA from a chromosome. Duplications can occur in any chromosome and can range in size from a single nucleotide to an entire chromosome arm. Again, it's almost the same as a deletion. There are several types of duplication as well. Tandem, dispersed, gene duplication. A tandem duplication occurs when a segment of DNA is copied and inserted adjacent to the original segment. A dispersed duplication occurs when a segment of DNA is copied and inserted at a different location in the genome. A gene duplication occurs when a single gene is copied, resulting in two copies of the gene. Some of the causes of duplication. These can occur due to errors during DNA replication. Again, misincorporation, slippage of the DNA polymerase, exposure to mutagens, radiation and chemicals, viral infections. Um, Duplications can lead to genetic disorders as well. Some of the effects: um, Charcot-Marie tooth disease, Parkinson's disease, cancer, um, birth defects as well, and as diagnosis is the same. There's several other ways, but FISH, microarray analysis, and karyotyping are all ways to detect duplication. But it is important to note, some of this is programmed. I think we should realize that some of these things are programmed. The body, I guess we could say, um, our our genes. Whenever a zygote is forming, some things are programmed. Some things are detected, but there is a lot of errors. You have to understand how complex these processes are. There's hundreds of thousands, millions of things going on at the same time. Just DNA in and of itself, ligasing or copying, it's a pretty crazy process. Um, I think I mentioned before, there are great animation videos if you want to see how a DNA molecule copies itself. It's a beautiful animation. It's really cool. And then you can see of course, all the Okazaki fragments and things like that. Even RNA itself duplicating or being synthesized. It's almost mind blowing to me. But there are great animations of all this on YouTube, online. You can find all this information online. So I just want to touch a little bit on inversion, and then I'll pass the torch on to Elizabeth. It's a type of chromosomal rearrangement that involves the reversal of a segment of DNA within a chromosome. There are several types of inversions. It seems that most of these, how would you say, these types of chromosomal factors or changes or variances, they all tend to sort of derive from the same mechanisms. I believe just the types of changes that they are is what changes the most, or what varies the most. I guess is the variance in the chromosomal structure. Um, but yeah, inversions they can occur in any chromosome. They range in size. Again, a few nucleotides to an entire chromosomal arm. Um, there's paracentric inversion, paracentric inversion. The errors that happen during DNA replication, and then the exposure to viruses, mutagens, and then of course this can lead to genetic disorders as well. So I'll let Elizabeth finish this off, and I hope you guys enjoyed this video. Hope you guys learned something. Again, if you have any questions, you can always Google. Google's great in the age of AI even. So I'll see you guys in the next video. Thanks. Sorry, I believe that was a mistake.